We'll look at time value of money. But before we go into calculating what time value of money is, I must make mention to say that under financial management, you need to understand that time is money. And the important terms we're going to learn in this session will be number one, what simple interest is. Simple interest is simply interest, not reinvested. So interest is only earned on the principal amount. So if you started with 100 kwacha, for instance, 10% of 100 kwacha is 10 kwacha. So meaning you're going to have 110 the following year, and 120 in the third year, and 140 or 130. You'll be increasing by a constant or consistent amount. So simple interest is simply earned on the principal amount, the amount we started with. Compound interest is simply interest earned over time for more than one period of time. So it is interest earned on the previous cumulative principal. So if you started with 100 kwacha, again, 10% interest rate will give you 110. At this time, we're not going to base the 10% on the 100. We're going to base it on the previous amount. So 10% of 110 is 11. So we add the 11 to 110, we're going to get 121. 10% of 121 gives you 12.1, and it goes on and on. But we're going to use a formula that will help us understand the simplified version of this. We're also going to be using key terms like the future value, which is simply the amount an investment is worth in future, invested at a time interest rate was given within a period of time. So we're also going to use what are called the future value interest factors, present value interest factors from the table, as well as using the calculator. Also, we're going to discuss the term present value, which is the current value of the future cash flows if they are discounted at a given rate over a given period of time. Now, to discount is simply to remove, or is simply the removal of interest from the future value whilst compounding in an additional interest. So if you're expecting 10,000 after 10 years, the 10,000 you're expecting in 10 years, today, if you're going to discount it because of the inflation and the interest rates, the amount will be discounted. So that is what is called the present value. So let me take you through the layman's approach. So if we're going to talk about simple interest, the formula for simple interest is simply PTR. P stands for the money you have now to the principal, T stands for time in years, and R stands for the interest rate. Now, let me dominate briefly on the time. Time is usually in years, but if it's compounded, we have annually, means the M, the number of compoundings we're talking about, is 1. Semi-annually, it means how many times are you receiving interest? Quarterly means how many times? Weekly and daily. So the compounding, if you're compounding interest semi-annually, it means you're receiving interest twice. Quarterly, receiving interest 4 times. Monthly, 12. Weekly, 52. And daily, 365, unless otherwise mentioned. So if this is a projection of how time can be converted. So if you're given 4 weeks, you're supposed to divide the 4 divided by 52 to convert it into years. If you're given 100 days, you're going to divide 100 days by 365 to convert it into years. So our principal times time times the interest rate gives us what we call our simple interest. Our compound interest formula is the difference between our future value and our present value. Future value is the amount we expect in future. The present value is the amount we have now. So future value has its own formula. It is given by the amount we have now, which is called the principal, 1 plus r to the power t. Our t is time in years. Sometimes we may use the letter n when it's compounded more than once. So the general formula for future value is simply as follows. Future value is equal to the present value, 1 plus r over m. Use the number of compoundings. And here m times time. So how do we use this formula, especially on the compound interest? As the examiner would want to ask, how much should we deposit now? How much do you expect in the future if we're going to deposit a present value of 1,000 kwacha for a period of time of 4 years? With an interest rate of 12% compounded annually. B, semi-annually. So here's annually, B, semi-annually, and C, quarterly. Just hypothetical examples so that you may understand what we are doing. So like I said, there are key things you need to understand. Whenever we are compounding, we are adding interest. So if it's annually, meaning in a year, you're only earning interest once. And the effect of compounding happens in such a way that the interest rate is always divided by number of times you're compounding. And the time is usually multiplied by number of times we're compounding. So part A, if you want to calculate the future value, since we already know the formula for the annual compounding, we're going to simply have our present value, 1 plus r. And now since our r is compounded annually, we can use this formula. It's okay. So our present value is 1,000. Our interest rate is 12%. So 0.1012. And our time is 4 years. So you must also note that the more we compound, the higher the figure. So I need your calculators to be nearby. So what is 1,000 times 1.12 to the power 4? 1,000 times 1.12 to the power 4. What are you getting? What are you getting?
1,570.
Your mic is quite noisy. Somebody else to help with that. I'll have to mute you. The mic is kind of noisy. Who else could try? The answer could have been correct, but the mic is, I think, noisy.
I was saying 1,573.519.
1573 point
0.519.
519. Okay. So if you're compounding semi-annually, the effect that the semi-annual compounding will affect the time, the rate R over M. So where there is 12%, we're going to put 0.12 divided by number of compoundings, semi-annually 2. So the rate we always divide it by the number of compounding, and the time we always multiply it times the number of compoundings. So here, clearly we're going to have 1000, then 1.06 to the power 8. So what are you having as the final answer? What are you having as the final answer?
1262.477.
One, one, one what?
62.477.
Is that what the rest are finding?
Sorry. I didn't put the power.
Your mic is noisy. I'll have to mute you. Your mic is kind of noisy. Please, I hope we're all calculating so that we are all together. Who else can? The mic is still noisy. It's still noisy. Try to use the other. You're logged on to two devices. Try to use the other device. Yes, Tamara, what are you getting?
1593.
1593.
0.848.
0.848. 0.85. Now this makes sense because the amount must increase the more you compound. So I want you to try to find the future value for quarterly. So what's going to change for quarterly? Can somebody tell me? I have 1000 here. Then 1 plus 0.12 over what? Quarterly over
It
what?
should be over 4.
Then 4 times what?
4 times 4.
Yes. So here we're going to have 1 point what? 03 to the power what? 16. What is our final answer?
Sorry, Mr. Collins.
Hello, yes. So we are dividing by 4 because it is quarterly. I'm multiplying the 4 years times 4 because time is always multiplied by the number of compoundings. The interest rate is always divided by the number of compoundings. For the first one, it was annually. We could still use this formula here and put 1 there and 1 there, but it don't affect any, don't change this any much. That's why we're using the general formula for the annual compounding. So the amounts that you get, the more you compound, the higher the figure. So this is what you're getting here. Any questions so far? So how do we raise the power on the calculator? Power on the calculator looks like this for a Casio and for a sharp y to the power x. So to raise the powers on the calculator, these are the two symbols that we use. So the formula is giving us mt or t here. So here, since we are compounding quarterly, we divide by 4 and multiply 4 times the number of years, which is 4 years. If there was 5, we multiplied 4 times 5, which is going to give us 20. 20 is not the number of years, but the periods. Because in each year, if we're compounding 4 times, meaning 4 times 4 will be 16 times. One does in books, we'll put n there. Are we clear on how and where to press on the calculator? Any questions so far? Okay. So now we'll go to, in the interest of time, we can calculate this later on. The figure will be bigger.
It's 1,604, 1604.71.
0.71. Okay. So the examiner sometimes at this point will ask you, find the effective annual rate. Find the effective annual rate. So the effective annual rate is simply 1 plus the nominal interest rate per m minus 1. This gives you there are 3 types of interest rates. So the effective annual rate is important because it gives you the real return on a saving that you put in a bank. It gives you the real return. It is simply an annual equivalent, or it's the rate of interest on a loan for a financial product related to it from the nominal interest rate. So the examiner may ask you to calculate the effective annual rate. It doesn't take account of time. So for what we're doing for a quarterly basis at the interest rate, at a nominal interest rate of 12%, you'll be asked to find the effective annual rate. So Let's try to find this from compounding, quarterly, and semi-annually. I'll do the quarterly and you do the semi-annual. Annual effective rate. So here you simply write 1 plus 0.1012, which is 12%. At M here, since it's quarterly, maybe 4, and here put 4 minus 1. What are we getting there? The annual effective rate of 12%. What are you getting? 0 point what?
0.126.
0.126. So, which is 12.6%. So try to find the one for semi-annual. What is the effective annual rate for annual payment? For semi-annual payment, we're going to have 1 plus what? 0.12 divided by what? What are you dividing this by?
2.
2, good, because it's semi-annual. And here we're going to have 2 minus 1. And what are you getting? What are you finding? Okay.
0.06.
0.06. Are you sure? So this will give you.
Oh, no. Okay. I was finding something in the bracket. Okay.
1.06 to the power 2.
Okay.
They're getting 1.06 to the power 2, the answer minus 1.
0.12.
Okay. 0.1236.
1236. So this is 12.36%. So this is called our annual effective annual rate. Now, sometimes the examiner would want you to ask to find any other. Okay, if you're given the future value of 5,000 and the present value of 1,000, and you're also given the time period it takes, maybe 5 years, compounded annually. Time it's taking is 5 years, and you're asked to find the interest rate. So here it will simply be an issue of what? Making something the formula. Can somebody help us? What is the formula? The annual, future value is equal to what? Present value 1 plus r to the power t. We've been given everything else here. Our future value is 5,000, right? Our present value is at 1,000. Our interest rate we don't know, so we're simply going to put 1 plus r, and our time is 5 years, so put 5 there. So for us to solve for r, we divide both sides by what? By 1,000. So this will help us cancel this side. So we're going to remain with a 5 on this side. So 5 is equal to 1 plus r to the power 5. Now, there's an invisible one here. We cannot solve for this r until we get the reciprocal, the opposite of this one, which is 1 over 5. Even here times 1 over 5. Whatever you do on the left side must be done on the right side. And 1 over 5 is the same as 0.2. So when this cancels, we're going to have 5 to the power 0.2 is equal to 1 plus r. So what is 5 to the power 0.2? Function a calculator. 5 to the power 0.2 to 1 point what?
It
Okay, you can try again. It will be what? 1 point. I had muted you. Sorry. The mic was noisy again.
okay. 1.37972
3797. Okay, so if you want to solve for r, this will go this side to subtract. So it will be 1.37 or 38 minus what? Minus 1 to be r, which is going to give us what? 0.38, which is same as 38%. That's simply making r subject to the formula, 38%. So it all comes from you understanding the first formula, then you make subject of the formula for the others. Okay, so
okay.
anyone lost so
And
far?
where did we get a 0.2?
Why did you get the 0.2? 1 over 5 is 0.2.
Okay. Thank you.
Why did you get the 2? If there was a 4 years there, I would have done 1 over 4, 1 over 4, which is 0.25 on both sides. If you want and you're okay with fractions, I've just put 5 to the power 1 over 5, just to give you the same. Right? Can we proceed? Can we proceed? Okay, so let me take you to now the exam questions. But before we go to the exam question, sometimes you'll be asked to find the time as well. Okay, how long will 1,000 kwacha triple? So tripling is times what? 3. So if your present value is 1,000, obviously the future value is what? 3,000. So the question may just come like that: how long will 1,000 kwacha triple? So present value, and if they don't give you a future value, just know that tripling, just multiply the answer by what? 3. So how long will 1,000 kwacha triple at an interest rate of 10%? How long will 1,000 kwacha take to triple at an interest rate of 10%? So here, compounded annually, you're just going to use the same formula: future value equal to present value 1 plus R. So if you're going to substitute where there is future value 3,000, present value 1,000, then 1 plus R, so 1.10 to the power t. So t we don't know. Divide by 1,000 on both sides. This side you're going to remain with what? A 3. Now whenever we have a power, a letter in the power, we're going to do something a little bit strange. We're going to introduce what are called logs. It's only a log that can drop a power down. So here we're going to have log 3, and here we're going to have log what? 1 point, log 1.10 to the power t. So because there's a log there, there's a rule which says that if you have log a to the power b, a power will have to drop to have b log a, b times log a. It's a rule, so meaning the t will drop here. We're going to have t log 1.1, t log 1.1. So to make t subject to a formula, we'll divide both sides by log 1.1. So meaning we're going to have log 1.1 here. So you go on the calculator, is a log sign that is on the on button now on top there. So you punch log 3 divided by log 1.1. Log 3 divided by log 1.1. So those of you who are using a Casio calculator, I don't know what calculator you have. There is log. I can show you just a quick image of it in case you're not sure. The log looks like this. So this is the log here. This is the delete button, the on button there, there's log here. Just press log 3 divided by log 1.1. What are you getting? Mic is noisy. Petronella, Tamara, what are you getting?
I got 11.527.
11.527. So it takes 11 years to triple. Okay. So now, how do questions look like? Let me repeat. How long does 1,000 take to triple? Here, put 1,000 and here 3,000. So you divide by 1,000, you have a 3, and you have 1.1 to the power t. So introduce logs on both sides. This t will fall in front of this one here. Then to get rid of the log 1.1, we divide on both sides. So this cancels, this cancels. This in there will be 11.5. So now let's go to an exam type question. You may not really give me the answer, but let's understand from what we've discussed. An investment company offers an account which requires a once-off payment or a once-off investment of 18,000 and grows to 2237 in 12 years. Find the interest rate investment is offering. So the 18 is the present value, the 237 is the future value, and the 12 is our time. So the interest rate is simply what we're explaining here. You make I our subject. So if we're going to look at the working here, at D, that is A, B, C, and D. So how long will it take? So here the present value is 237. Our future value is 237 and the present value is 18. So when you divide this in there, you solve for our x there. So this divided into there, then on both sides you're going to divide 18,000 here, 18,000 here. The answer here, because it's power 12, so you reciprocate both sides, the answer you get by 1 over 12. 1 over 12. So you remain with your final answer as 24% as the interest rate. Although here a shortcut was used, but from what I've just explained, are we able to remember how to do that? So this is one of the questions that were done from your previous exam questions. Is anyone lost on this one, or do I need to explain again? Is anyone lost on this one, or I need to explain? Please feel free to ask. Anyone lost? Feel free to ask. So this is a question. It's asking for us to calculate the interest rate. So from the figures we have here, we can say our present value is 18,000. And we have our future value, the amount it is growing to, which is 23787, and our time in years is 12. So future value is equal to present value 1 plus r. So we're solving for r. So here we're going to put 237. And here we have 18,000. We're just scrubbing out the zeros. And here we have 1 plus r to the power what? Time, which is 12. So we know this is the power 1 there. So we multiply both sides by the reciprocal, which is 1 over 12. In here, 1 over what? 12. So here, cancel here, we cancel. So before we do the 1 over 12, we divide both sides by 18. 18,000. So if this comes out, then the figure we get there is what we divide by, that we power to 1 over 12. So when you do that, you'll find your final answer will be 24%. Okay, so this is how basically we do our compound interest and how we do the simple interest. Now what follows are annuities, then you go to amortization schedule. Don't know if there's any more questions at this point. What is the present value of 300 kwacha or $300 received 2 years from now, discounted at 10%? Now here, we want you to know how much this 300 kwacha represents today. You can use a number line to illustrate. You can use the interest factor table under present value interest factors. So this 300 kwacha is assumed to be received when? 2 years from now. So in year 2, sorry. So 300, we'll need to discount it to the year today. So to year 0 today. The formula for the present value is simply the cash flow divided by 1 plus R to the power n. So our R, in this case, has been given as 10. So we're going to have 300, 1.10 to the power 2. So if you divide this in there, the final answer we're going to get will be 247. 247.92. So this is the present value of 300. This is the present value of 300, how much it's worth today. So this is how we calculate the same future value interest. Sometimes we may have streams of money. What future value at the end of the 5th year will you have given the following streams of payments? In year 1, you have 300, year 2, 200, year 3, 150, year 4, 400, year 5, 200, and the interest rate for each of them is 15%. So these future values collectively make what we call annuities. So annuities are a series of equal payments. But we're calculating the future value, this 300 kwacha, we're going to multiply by, this is year 0, year 1, year 2, year 3, year 4, and year 5. So what is the future value? The year 5 one will not grow because it's just in the actual year. Year 4, we're going to use the future value formula. So future value is simply equal to present value 1 plus R to the power n. So This one, the present value here, put 100 kwacha. In 1.2, what's the percentage? 15%. But on the end here, since it's only staying 1 year, we're going to put 1 year. For the 150 to year 5, 1, 2, it's going to stay 2 years. The 200, 1, 2, 3. The 300, 1, 2, 3, 4. So this is how we're going to break it down. So using the number line, you're still able to find how much each of these amounts will grow to at the end of the period. You can do it manually, or you can use what are called annuity tables. They'll give you discount values if you are to check in the table. So in our next session, we will now look at annuities and we'll balance up the ANOVA, the amortization table. So unless there are any questions, I can end here.